do they record it?
We record it.
Okay.
Okay. This meeting is being recorded. Nice. Okay. So yeah, iPad is doing everything. That's just there to present
Okay.
the slideshow.
Nice.
Okay. Now we wait.
I moved the telemetry reader somewhere, or did that kind of somewhere else? Or is it fine right here? Okay.
All right, we're in the meeting. No one's joined yet, but just so you're aware.
Okay.
Sure. The iPad is doing camera, audio, or camera, microphone, and speakers. Computer is just there to present this slideshow.
This piece. So it's next to the rocket here.
Yeah, you want to grab those ones too?
Oh, yeah.
I think it's almost dry.
Yeah. It stops like moving after like an hour. Why don't we stand it up?
Yeah, we can stand up.
Whether or not, because it makes it easier to show off the inside if it's not. But
Okay. The nose cone tip is not screwed in.
got it. I feel like we should just have it next to the nose cone. So I feel like one of us is going to forget. This I don't want to mess with that. There's a small box that has the rest of it. Or is it already out?
Bottom shelf.
And our parachute.
It should be there. Right.
Oh, I see it. It's just right there.
Oh.
That's fine. I want to make sure our recovery gear is not going to be a nightmare to pack when we're done. I don't know if that's going to happen today or tomorrow, but yeah. And
Oh, sorry, I'm in the state. Sorry, can't do anything about that. What a shame.
Jared.
Left. I would have expected someone to show up early. Surprise no one.
so yeah, still got 5 minutes. Is these things been completed by the video review?
Yes.
Okay.
So we've been building a rocket all week. Oh, Spencer.
Over here.
This is unusual. I usually have to remind everybody that we need to record.
Yeah, I already have the recording started.
Perfect. And you know where to send the recording. Well, you know where to send the link to the shareable drive to the file is, right? That was in my first message. Yeah. Okay. All right. Are we expecting anybody else?
Yes.
Okay. All right. I'm gonna step away for a couple of seconds. I'll be right back.
Okay.
You guys want to go out? So, David,
What was that?
I see that you are level 3. Is that correct?
That's
I
Kevin over there.
I'm level 3 certified through Tripoli.
Okay, so you're David. Oh, okay. Two Davids makes it, well, Duncan. I'm sorry. I'm sorry, Duncan.
Oh,
Could you just,
Yeah.
yeah. I was just gonna ask you, you're a level 3, Tripoli level 3?
Yeah, I got my level 3 this past January. Our flyer of record for the competition is not here right now. He's James Shower. He's not here right now. But he will be our flyer of record for the competition.
Who's gonna be the flyer record of the competition?
Duncan
Duncan
Shower.
will be, right?
Yeah.
Okay. Okay.
Everyone.
I guess I'm getting confused. Are you,
Oh, okay.
are you Duncan?
No,
I'm Kevin.
You're Kevin. Okay. All right. All right. So Duncan got his level 3 in January. Is that correct?
I got my level 3 in January. Duncan got his last September. Yeah.
Okay. Okay. So we got multiple level 3s on the team then. Cool. That's the first. Good. All right. I assume since you don't have much flight experience at a level 3, right?
No, the only level 3 flight I've done was my certification flight. I do have. Let's pull apart. Yeah, it's like I want to tilt the thing down a little bit so you can see us better. But
Yeah, that's better.
my I have quite a bit of flight experience at the L2 impulse range. I've flown plenty of J's and K's, but at the level 3. So sorry. At the level 3 impulse range, my only flight right now is my certification flight. I was as an Aerotech M1350.
Okay. Okay, that's good. That'll work. All right. I'm ready anytime you guys are, so if everybody's present, that's great. If not, we can still wait a little bit.
Just wait for Bryce, right?
Yeah. I think Bryce is the only one who's not here yet. What time is it? I'll give him 5 minutes and then we'll start if he isn't here yet.
Okay.
Oh. We don't need a separate wire battery for the tunnel. Sorry, the 90 6 hours. But, good. I got it to make a GPS log. So
Inside the building?
no, I went inside of it. It didn't have it built. Yeah. Didn't get very many stats, but that was also because I was right next to the building.
Right.
So as long as we get the featherweight in time, we'll have redundant tracking and telemetry. Okay. So we just have to wire everything for.
Who are we waiting on?
Bryce, Janice.
Yeah, okay.
Send him a text message real quick.
That's sometimes
It's possible.
Yeah, there he is.
Oh, there we go. Cool.
Good afternoon, guys. Sorry I'm a few minutes late.
I guess all good.
Duncan joining in.
So Duncan is in Africa, and unfortunately, his connection is not reliable enough to join in on video. And so what we've compromised to is that Duncan will do an in-person walkthrough once he gets back from Africa, and we'll cover everything that we talked about in this meeting with him. And then we'll record that meeting as well and submit both files.
Okay, that sounds good. And we can proceed.
Alrighty. Welcome everyone to the Team 32 video flight readiness review. That's final review. And so our current progress, we've got the airframe 90% complete. We're just waiting on one last piece of hardware that's arriving tomorrow. But all components are in CAD and bonded, minus one last centering ring that we're waiting for some epoxy to finish setting for before we put in. You can see some of the pictures. Construction process. For the avionics bay, sled design is complete. The flight computers are finalized and we've confirmed they work. And batteries are confirmed that they work and integrate with the computers well. Payload, the payload testing is still in progress. So just a quick recap for those who aren't aware, our payload goal is to be a demonstration of a live stream video feed technology system. And so we've been running into some minor issues with the antenna transmitter getting really hot really fast. Our guy who's the expert on that says that if we swap out the antenna for a different one, it should hopefully alleviate itself. And so we're just waiting for that antenna to get here in the mail. But the mounting system is also conceptualized. We just haven't finalized anything because we haven't finished or haven't gotten it fully working yet. But in short range tests, it does work before the heat starts thermal throttling. Test flight is going to be occurring next Saturday at the NAR SSS chapter in Arizona. The reload for the motor for that flight is going to be picked up today, immediately following this review. The launcher site has been unresponsive though, and so we're unable to confirm that they've got a big enough rail. And so if we are unable to get a rail confirmed for that site and they end up not having a rail, our backup date is in 2 weeks at Tripoli, Vegas. That's the main overview. I guess now we can just go into more of the nitty-gritty review and hands-on part.
Yeah, I'm gonna need to basically see. So if we want to start with the nose cone and work our way towards the aft end, that's fine. I don't want to recover, go over parachutes, you know, all that stuff. So, and I also want to go see the electronics bay.
Okay.
So recovery harnesses, parachutes.
Nose cone.
Could you, okay. Could you get rid of the, yeah, there we go. Thank you.
So
Nose
got the
cone
nose
without a tip. Okay.
yeah, the tip's on the
Just
table.
here, it just screws on. There's a we're gonna have an eye bolt that goes in here, and then there's another piece that fits on top of here, and there's another piece that screws on the inside.
Okay.
Yeah.
Okay. One of the, if you want to call it a highlight of our nose cone, is that to ensure that we meet the joint requirement that joints need to be one body caliper of contact, we had to extend our nose cone a little bit. And so we've got a butt joint here secured with epoxy, and then we've done a wet layup of a fiberglass sheet on top of it just to give it a little extra reinforcement.
Okay. Is there any electronics or anything inside the nose cone?
No.
No,
Not
all of
currently.
our electronics are going to be housed inside this coupler. It has enough space for both our payload and our flight avionics.
Okay. Where is that coupler go? Okay. Okay, so the nose cone stays permanent. It does not come off.
No, the nose cone separates. We're doing head end dual deployment. So it will it'll separate from
Grab the
coupler,
payload
and then
placeholder. Can
It goes in there.
Okay, what's okay, what size of shear pins?
We're using 440.
For how many?
how many?
If I remember correctly, we're going to.
Yeah.
so
I forget. It's.
Yeah, okay.
but we're gonna put
I want to say it
the
was 6.
but when it comes to the
Yeah,
shear pins, we're going to put them before the butted end of the nose cone. That way we can ensure that you know, just a safer method of doing it in case that would shear this off. I don't think it would, but it's just a safer method. And then so the parachute will go in the nose cone, and there will be a eyeball at the top, and then we'll all go together. This. Maybe to fit better together.
Yeah, I think the
With
bulk,
sanding,
might need to
but-
sand the bulkhead a little bit. That's fine.
But yeah, this would go all the way down, and then this end would go into the rocket, and so both of these sections would separate. And we have 2 recovery harnesses for each section that would separate.
Okay, describe the recovery harnesses for me. What are they
Describe
made
the-
of? What's their
Oh, the
strength?
harness? These harnesses are Kevlar. They're tubular braided Kevlar. So we have 40 feet. What diameter are these?
Half
It says
inch.
on there it's half-inch.
Oh, half-inch. Okay, so we have 2 40-foot half-inch Kevlar harnesses, and what's really cool about them is the way we bought them. They already had the end sewn together, so it allows us just to pass the harness through itself through the loop to make a really nice, strong connection with the eye bolt, and that way we don't have to worry about tying a knot that is strong enough, or use a quick link.
Yeah.
And these work out really well, and they're both the correct length for our drogue and main, and they're strong enough to withstand any sort of shocks that we've calculated from the rocket if it were to be traveling at a high horizontal velocity at apogee.
The
Okay.
rated load on them
just-
is
What is
They're-
what is it?
1,200 pounds.
1,200 pounds.
It's not 1,200. It's like,
It's gonna be higher,
it's a lot higher than that. I want to say it's like 6,000 pounds.
but our eye bolts are rated to 1,200.
Yeah.
So
My understanding is,
Okay,
what Duncan has explained to
Yeah,
me is that
could
the
you
eyebolts
show
have
me
a
an
very large vector of safety.
we did it.
Wait,
I'm sorry.
what was that?
can you please show me an eye bolt? Can we show,
Yes.
can you show me one of the eye bolts, please?
Oh, it's in
It's,
the.
it's in here. Kevin, you want to help me separate this? Or yeah, you can grab the
I
other
just
one.
have the other one. That's what I found, yeah.
Okay. So we got,
Okay, closed force. Perfect, okay.
Yeah.
All
we
right,
have,
that was what, 3 size? Half inch,
That was 3/8.
3/8, okay, all right. Now let's go back to that coupler. Can you take those off for me, please?
Yeah, yeah, yeah.
yeah.
And I also wanna see the parachute that you're gonna pack in there and how you're gonna pack it.
Say it one more time? He's wondering how we're gonna pack the chute.
That is
I
one
wanna
of
know,
I was going to figure out immediately after this review. Our main parachute is pretty big. It's bigger than something I've flown before, so I just want to go over it a couple of times and make sure I know what I'm doing. I'm probably going to talk to Duncan about it because he's designed this for
Designed similar.
designed a similar system for Deneb 2. That if I remember correctly, uses the same model parachute. So I'm going to double check with him and make sure that we're packing it correctly. The drogue parachute is it's a 36-inch recon chute, so that one will be pretty easy to fold.
We've flown these before.
Yeah, I follow the they're pretty similar to sky angle chutes. So I just use the sky angle packing tutorial for their parachutes for these recon chutes,
And they have a
and
really
that's worked
nice,
pretty well for me in the past.
they have a real nice CD as well.
Yeah.
okay. Who made the parachute? Who's the manufacturer?
It's recon recording. I believe.
I'm sorry?
I can't remember if it's manufactured by Wildman or if it's just
Recon
Wildman's
Recon recovery.
Yeah.
Oh, it's a recon, it's a
Yeah.
recon, okay, all right. Right, okay, I'm sure with those, okay. How are you gonna protect that?
We have a couple of, well, for the drogue parachute, we have an 18-inch Nomex parachute protector. For the main parachute, we have a 30-inch one. I believe I used recon chute protectors on my L3 attempts, so these are pretty good.
We also have experience with pop testing and flying these chute protectors, and sometimes they burn through.
That was on the ones that we made. These
Well,
haven't-
no, even on those they burn through. Okay, well, We plan on using, on top of that, some cellulose insulation, just as a little bit of extra protection. This is a nice
Okay.
barrier. Yeah. But we'll be using
Okay.
both.
All right. Okay, now. Can you show me your electronic sled, your recovery sled
So
with your electronics mounted?
they're not currently mounted, but we have 4 holes, which will have 1/4-20 all thread passing through, and then we have a 9-volt battery holder in the back, and then we have all the spool patterns for the electronics. So the featherweight tracking, the Telemega, the Easy Mini, and if the Easy Mini doesn't work or if we have issues with it, we have hole patterns for an RSC3, just as a backup. And the way we're going to mount them is we have some screw-in offsets that we're going to use CA glue, and we're going to put them into the sled, and they stand off from the board, from the sled, and then we're just going to screw the boards in with the appropriate screws. But this should all sit on top of our payload.
How are you gonna run your threaded rods that way?
Yeah, so we have our threaded rods, and then
There's 2 more. They're
and we can use the mock-up bolts that we have. So the threaded rods will run through with 4 of them, and then we have this is a mock-up one that we made out of plywood.
oh, for the bulkhead.
Yeah,
Careful because those aren't like attached.
and then they will all slide through the bulkhead. So,
I see.
4.
Yeah, okay. I couldn't tell from,
And then in the center,
I could tell from. Okay. All right. Now, how are you gonna mount batteries?
Can you repeat that?
How are you going to mount your batteries for your electronic?
Yeah, so this sled is a test print. We have one battery holder here. This is probably going to get modified because this print didn't come out particularly well. In our CAD file, basically, I'm just going to add some little slots for the batteries to be held in. You can see there's this basically you just slide the battery straight in there. And then I have these little overhangs here to allow us to wrap a zip tie around the front, and that'll hold the battery in place. And this technique is very similar to what I did on my level 3 attempt. I just had little slots for the batteries to fit into, and then I zip tied them in. And that worked pretty well.
Okay. All right. Now, can you show me how you're going to, your hard points for your parachutes on your bulk plates?
Where's the bulkhead still in the nose cone?
yeah, I can get that out. But in the meantime, we can show the motor.
Yeah. All right. The way that Duncan recommended us to do this is basically there's a threaded hole here in the forward closure of the motor case. We can screw an eye bolt into there, and that will act as the anchor point for our shock cord. We can basically just attach oh yeah, that's the bulkhead. But yeah, for both ends here. Actually, let's grab that extra eye bolt so we can just see that how that would look. Conceptually, it's the same on both ends. It's just an eye bolt, and then we can quick link the eye bolt and the sewn loops and the shock cord together.
Kevin, where is that extra eye bolt?
It's in that box.
I have this one. But
That's
not
what.
the one
Yeah, that's what I'm saying. That was the.
That's okay.
The other one is.
That's
in my
okay.
box.
I'm familiar with that. That's okay.
I just
And then the nose cone side.
And
Okay. Well,
then we have this bulkhead
guess what?
here.
What was that?
I was gonna say one thing, ask one question about the on the motor. How are you gonna make sure it doesn't twist out?
My understanding is that, because I haven't used this method before, I'm gonna double check with Duncan about it before we actually use it. But my understanding is that we can, have a nut on here also, and then use that nut to basically compress the threads, and so it will be held in there by a lot of friction. I'm not sure exactly how
I'm
that
not
works.
a-
Check with Duncan, make sure that that is how that works, but
Yeah, you may wanna look at double downing it, or you may wanna look at possibility of putting in some sort of thread lock.
Yeah.
Yeah, the blue thread lock, for instance, or
Yeah.
something like that. I'm not convinced what you just told me. That there isn't the possibility of it spinning out.
okay. Yeah, I believe we do.
So
have
anyway,
We have
thread
blue.
locker, so that should be, okay.
We've got
The
the
issue with using thread locker is that this is not our motor case, and we don't want to.
See, the person who owns it is in the call,
No, I know.
so we can ask him if it's okay if we can put blue thread locker on his motor case.
well,
Right.
you can also solve that problem. You can also solve that problem by putting a swivel down there.
Yes,
Oh, swivel.
yeah.
Yeah. Well, the swivel would have to be rated for.
I mean, the drug parachute has a swivel. I'm assuming you mean for the shock cord.
Yeah.
Yeah. Oh, yeah, yeah. It's
That'd
against
be
the
a-
twisted.
beefy
Yeah,
swivel.
something to ponder and something to think about. But
I think we have a couple swivels.
yeah, I've never seen.
I just don't remember where they are, so we'd have to look for them. But yeah,
Okay, but I've actually seen the Bible twist out and everything fall apart. So okay, let's go back to let's talk about switches and how they're going to be mounted and where for the electronics.
switches. Where are they? Okay, so this is going to be rewired, but we basically just have a screw switches that were purchased from Wildman. These two particular units haven't been flown before, but we've had a lot of people in this club fly these screw switches in the past, and they've worked really well. I believe for the featherweight, what we're going to do
What kind of
is
switch? What
they're screw switches. So
can I? They're screw switches. Oh,
yeah,
okay, fine. All right. Perfect. Okay. All right.
And then they will be mounted onto this
yeah, on the inside of the
inside of the switch band right there.
Okay. All right. Can you what? It's hard to. Okay. What else? Let's see. Where's your payload going? Where's your payload going to be at?
So the payload will be directly under the avionics sled. It's an
So we'll have a bulkhead here, and it will go top the rocket, and then there will be all thread passing through the rocket. So our payload box will sit on the hull thread, and then we will load it to the this part of the rocket.
The mounting system for the sled, or for the avionics sled, and for the payload are basically they fit onto the same all thread.
Yeah.
And they stack on top of each other inside that coupler.
Okay. That's different. All right. How are you going to turn the payload on?
So in the switch band, right? We're doing it through the
For
switch
the
band.
payload. Yeah.
Okay.
oh
Payload.
payload.
Oh, if the payload turned on.
Payload will be turned on before bringing it out to the pad.
Yep.
We verified that battery capacities are big enough to make it work with that practice.
What's big enough?
I can't tell you the number off the top of my head.
Suppose I said that from the time you left your tent to get in line, get it safety, get out to the pad, and the button was pushed was an hour and a half to 2 hours.
How long?
Mm-hmm. Before you
Can you
much.
repeat? Can you repeat that?
Sure. What if I told you that from the time you turned it on until it was launched was an hour and a half?
Oh, that's,
Yeah,
That's plenty of time.
yeah.
we've accounted for 3 hours.
Yep. And we have 1,500 milliamp hours or 1,450 on the battery that we've chosen, so.
Yeah.
Plenty of time.
Okay. Okay, all right. What do you use for tracking, for GPS tracking?
So we're using it's in the mail right now, but we're using a featherweight GPS tracker, and then the Telemega also has a GPS module and radio antenna to transmit the GPS coordinates back to us. And then our ground station.
Oh, okay. So we have this, the antenna, there's the teledongle here from Multispectrum that is designed to be used with Telemetrum and Telemega flight computers. That's this little blue box right here. And then it's connected to a laptop via USB. And we can use the Multispectrum software to monitor the flight data as the flight telemetry as the rocket is in flight.
Okay. Just describe how your rail buttons are mounted.
Say one more time.
Your rail buttons. How have you mounted your rail buttons?
Oh.
That's a good one. So our rail buttons. Yeah, you can. So I'm gonna move the rocket.
If you look inside the app, then you can probably see.
So we have two 1515 rail buttons that we have these chamfered screws that go into the top, and we've epoxied them in onto the body, and then at the bottom there's a rubber nut of sorts that as you tighten it more, it springs back with the same force. So it's very, very tight, and we've epoxied that in as well. Then we have the exact same thing on the other side of this. However, when we drilled the hole for this, it is the coupling section of the rocket because we couldn't find a tube long enough to make this all one piece. So there's a coupler inside which doubles or triples the thickness of the fiberglass where we had to drill this hole. So it added a whole lot of extra friction between the screw and the body, but that just seems like a plus to me. And then the same thing, we have the rubber nut on the inside, epoxied and screwed in. And we made sure that this is
all right.
Slightly after the CG, and this one is above the.
Yeah, remember from the open rocket, I believe this is 4 inches from the aft end.
Right.
This is
About
say 6 inches from that joint there.
Yeah.
That's fine. You're absolutely fine.
Okay.
Go back to where you joined your tubes together.
Yeah.
That's
So
what I'm yeah.
So Wildman only sold these 8-inch fiberglass sections in 48-inch long pieces, and this section is longer than 48 inches. So we cut off some of this and made this as a fin can, and then we took this and glued the coupler in on top of the centering ring. That way, the coupler in a way acts as a centering ring, and then we glued this top tube onto the coupler to connect it to the rest of the rocket.
Okay, so the rocket, so you basically glued the coupler in place.
Correct.
Yes.
Yep.
Okay, perfect. All right, now let's go down to your fins.
Okay. So we did.
No, it's the one.
It's on the side.
Yeah, it's definitely.
Yeah. So our fins, there's a lot going on. So when we first calculated the thickness needed for the fins to mitigate fin flutter, we settled on 3/8 of an inch following the modulus of elasticity of Garolite or G10. So purchasing a large sheet, we water jetted the shape of the fins out along with the centering rings and bulkheads. And then we slotted them in place. They have fin tabs, which connect to the motor tube and push up against the centering rings inside the rocket, which adds a lot of strength to be able to handle the impulse of the motor that we're putting in.
And they have
Okay.
internal and external fillets.
Yes.
Yes.
Okay. What epoxy did you use?
We use Proline 4500.
Stuff that Wildman
Okay.
sells.
Yeah, it's what Wildman recommends, and we've flown it many times and used it many times, and we're big fans of it.
Yeah, it's fine. Okay. How are you gonna do motor retention?
So we purchased a 98mm Aeropack retainer.
That's the one component in the mail.
Yeah, that's the one component in the mail that comes tomorrow. That's gonna get mounted to our aft centering ring, and then we just finished our internal fillets this morning. So basically, the only remaining step for this part of the rocket is to mount the motor retainer to the aft centering here. Just to mount the retainer to this ring, and then that gets glued in place in there. That retainer is mounted with a bunch of, I think it's 1032 hardware. And then it's just, I mean, I'm sure you're familiar with an Aeropack retainer.
Okay. Okay. Can you describe when you're gluing things together, your surface preparation?
Yeah. So we like to sand down. So for everything, we have a pretty set procedure of that. We use 220 grit sandpaper, and we sand it, and then we wipe it down with ISO, and I'll probably repeat that step 2 or 3 times where we're bonding, and make sure that it's completely free of debris when we wipe it down with ISO. And we make sure that both sections that we're bonding have had that surface preparation. And then we take the Proline and we bond them together. We make sure that the Proline is mixed the right ratios and covering enough surface area to where it'll be a strong enough bond. So you can actually see that on our fins. We prepped them before putting them into the rocket, and then we prepped them after putting them in the rocket. So come up here.
Yeah.
You can see the change in the color is from us using the 220 sandpaper and then wiping it down with ISO. And we did that probably 3 or 4 times for each fillet.
Okay. I think we've gone over all the basics. You still got a lot of work to do, but it is what it is, I guess.
We're
on summer break now, and so
we're on summer break, but we're also pretty confident that we're on schedule. The last major component that we have to glue together is that aft centering ring and motor retainer, and then past that, the rocket can be fully assembled, and will be.
It's just avionics recovery.
Yep. From there, it's just the recovery system, which we're pretty confident we can get done in time. And after our first test flight, it goes off to the paint shop.
Okay. Look, like I said, you still have some work to do, and I'm really glad you're going to do a test flight. I hope everything goes well on the test flight, and you don't have to do any kind of damage repair or anything like that. So overall, I think you're in good shape. You're about where everybody else is. Some are a little further along. It's not uncommon to see what I see here right now. Let me reverse the tables and let you ask me questions. Do you have anything that you would like to ask me?
Kevin?
Hey, guys, this is Mark Benton. Can you hear me okay?
Yeah.
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 So,
I think we-
I'm the faculty advisor going with these guys, and I just got a few questions. Hey, David, when and where is your test flight going to be?
You know the exact location?
I can find it.
It's about 3 hours south of here. And it will be next Saturday.
Okay. All right. I'll talk to you some more about that. Second thing is on the fins. Can you point the camera at the fins, the leading edges? It looks like you have like pretty blunt leading edges. Are you gonna do any kind of filled-ing or rounding of those, or is that you just gonna leave it the way it is?
So that is intentional. We were not confident that we would be able to create a chamfer even enough for both sides with such large fins.
Yeah.
And so we decided just to leave it blunt. Our motor provides enough total impulse anyways that it doesn't really change our flight performance that much.
We lose a little bit, but we're still well within what we would consider reasonable. I mean, if we previously we ran simulations with these edges beveled, and we were actually above our target altitude. So leaving
Okay.
these square actually puts us closer to 10,000 feet.
It also allows us to have our simulations be more accurate
Yes.
with
Yeah.
the shape of the fins.
Okay. And lastly, the pieces that come apart, looks like you have a big slip fit on the I guess it's the payload housing and the parachute housing. And is there any kind of treatment you're going to put on there to keep that from maybe binding up? And I'm thinking of, differential thermal expansion could cause that to possibly bind up when it's trying to separate, things like that.
We've never had that issue with our own personal rockets, but usually what we do is we make sure that it's big enough to where if it were to expand a little bit, we can still slide it off. But also what we like to do is we check how well it slides pretty frequently, and to make sure that it stays concentric with the tube and that it slides nice and easy. We like to cover it in masking tape, and that usually gives a pretty good even sliding surface for the nose cone. But right now it's pretty wide and slides out on it pretty easy. The only issue that we have is that it traps air, so there's going to be built air pressure when we slide it down, but the ejection charge is going to build air pressure when it pops it off. So that's only an issue when putting the nose cone on.
Okay. So you don't have any vent holes in that thing, right?
We
Not
will,
yet, we will.
but currently no.
Okay. All right. Just a couple of concerns I saw. Sounds good. Thanks, guys.
Yep.
Keep me in Leslie, keep me in the loop on your progress.
Yep.
Okay, thanks.
Okay, when are you planning on ground testing?
We're gonna ground test the 16th, the day before we fly.
Yeah, day before we leave for the launch site.
We just don't have the capabilities to ground test here in Prescott because the ejection charges are so large. We're afraid it's gonna cause issues with
Safety would not
with,
be a thing.
yeah, with safety and just everyone else here.
So we have to.
So,
yeah.
what size of ejection charges are you looking at?
Eight,
I
9 grams.
need to double check the calculator that Duncan gave me,
9.
but yeah,
It is
we're
8
looking
and 9.
around, 8 grams.
That sounds awful big. How big? 6-inch rocket, 8-inch rocket,
8-inch.
8?
Yeah.
Yes.
Okay, maybe. But definitely ground test, obviously.
Yes. Yes.
So, on that.
Absolutely.
Okay. What kind of, can you show me your charge wells?
Can you repeat that?
Because they're gonna have to be really big. They're gonna have to be really big to hold 8 grams.
Oh, the charge wells. We're going to be using shooters We're gonna be,
Using,
So here, I can explain. So
Yeah.
because we're using head and wheel deployment, essentially, because our main parachute is going to be in our nose cone and the separation point is down here, if our ejection charge is on the is like directly on this bulkhead, what can happen is the pressure from the ejection charge firing can push the parachute further into the nose cone, and sometimes it can get stuck. So a lot of times what you'll see on head end rockets is you'll have a long like ignition lead wire, and then the ejection charge will be placed towards the top of the nose cone, and then it can push the parachute out, essentially. So we won't have charge wells on the actual bulk plates, but yeah, we'll have a little.
We have little plastic shooters
Yeah.
essentially that will be filled
Yeah.
with black powder and then wrapped with duct tape to help build pressure
Yeah.
as the black
Put
powder
some-
combusts.
Put some dog barf in there too.
can you, what do you mean, when you say shooters, are you talking basically a tube, a rubber tube?
No, we're
Right.
talking about the 2-ounce bottles of alcohol that you buy
But without the alcohol.
without the alcohol. So the little plastic,
Glass?
one bottles, no, plastic.
They're not
Uh,
really the shooter glasses, they just look like them. And so
Yeah.
that's what we call them.
you have one?
Um,
Not
somewhere in the flight cabinet.
Oh, yeah, it's
that's-
probably in there.
It's quite the dig.
I know, Altair used that method. I think Danette used that method too, right? So we know it works.
Yeah, I don't know where they. The ones we are using are technically the property of another team, and so we need to double check on with them on where exactly they are in the cabinet. But they're somewhere buried in a cabinet.
We can get more, that's not an issue.
Okay.
Yeah. Very easy to
Oh, yeah.
I have a ton of images. Powder and fire cabinet for that, so I'm not worried about that.
While you guys look for that, an easy question, what motor are you guys doing for the test flight?
N3300.
Oh, okay, cool.
It's for the competition flight.
Yeah.
And double checking, you guys have already purchased motors. You're just waiting for an extra one to be delivered this week?
We are driving down to Phoenix. Our supplier, Animal Motor Works, is down in Glendale, and we're driving down to their place of business to pick up the grains today and the rest of the reload kit.
And that's for the test flight. Do you already have your motor for the event?
Yes.
So we purchased the motor for the event, but the supplier Wildman will be at Spaceport America with our motor in their trailer. So we will pick it up from them when we get there.
Got it. Okay, just making sure.
Yep.
Here's,
Okay,
this isn't exactly one of the shooters, but it's approximately the size. Just a little like vial here.
okay. All right. You want to describe how you're gonna put the black powder in and seal it and A-match and all that sort of stuff for me?
Yeah.
Yeah.
So we're
So-
gonna make. Okay. All right. Yeah.
So basically what we can do is basically just, the first step is to just you measure out the correct amount of black powder, pour it in here. Set the E-match head on top. And then what I like to do is fill the rest of that vial with, a bunch of like, either like Estes recovery wadding or, dog bark, yeah. And then basically just either, I mean, this has a cap honestly, so you could probably just screw that tight and then, probably duct tape that, or glue it, one of the two.
And so you forgot to mention,
I did.
we'll put
Yeah.
a blob of epoxy more or less into the vial first.
Oh, yeah,
to
yeah, yeah,
act
you're right,
as a
you're right.
Cap for the pressure, and then, once
Yeah.
it's screwed on, it'll be wrapped with a couple layers of duct tape that will allow the black powder to fully combust before the pressure seal breaks.
how's the, match coming there? How will you mount,
oh.
where,
Sorry, drill a hole in the cap,
Yeah.
and thread the E-match through before the cap gets sealed on.
okay, and that'll be sealed off, right?
Yes, yeah.
Okay. Different, okay, that probably will hold. Definitely hold 8 grams of powder in that one for sure. Okay. That's still a lot of powder, but anyway, your ejection charge will finalize that, so, or.
Yeah.
Back to the ballpark anyway. Okay, like I said, any questions for me?
Nope.
I don't think so.
Yeah, not that I
Nope.
can think about, but I think we had a lot of the remaining stuff to do conceptualized.
Okay.
Just need to like actually do it.
Okay, have you guys got your final report in?
Yep, yes.
All right, just a couple of things, you don't need to bring tents this year, because we'll basically to the parking lot. So, we'll give you all kinds of shade cover, you don't have to bring tents with you. You
Okay.
don't need to bring tables, because we'll provide tables, 2 tables per area. The area will be roughly the same size as you had last year on that end of it, okay? So make things a little bit easier, keep you out of the shade. The other thing we're going to do is we're going to a pager system that you get when you get to registration, and the pager system is very similar to what you get at a restaurant. So, for instance, when you're in New Mexico and, oops, hold on a sec. And, you're getting ready to go for your final safety check. You won't have to stand in the hallway. You'll get paged to come and bring your rocket and get it safety checked. That pager will follow you out to the field also. And, you'll be paged when you're needed for various things like final check-in, stand in line to go to the pads and so on and so forth. Okay. So that's a couple of things going on, that will make life a little bit easier on that end of it, so. Okay, so registration's done, final reports in, completion of is on schedule. And I guess your guys are ready to get going.
Just about.
Yep.
Okay. All right. We can stop the recording.